Good evening. In previous session, we have seen the basics of inter-thread communication, and we have seen how to implement the concept of inter-thread communication by using the concept of event class. Now, in this session, we are going to see two more mechanisms that how to implement the inter-thread communication in our Python. So, in yesterday's session, we have seen about what? We have seen about event class. In today's session, we are going to see about condition class, and also we are going to see about queue class. So by using these two, we are going to implement inter-thread communication. So we are going to see these two classes in this session. Okay, right. In yesterday's session, already you know how to implement the concept of inter-thread communication by using the event class. So there, how many methods we have used? There, two methods, mainly two methods we have used. One is what? Set method, and second one is clear method. And also we have seen about wait method also. So to check whether it is set or not, we have used isSet method. So what is the use of this set method? So whenever the flag is going to be set of an event object, then the threads can access the data or access the method. So whenever this internal flag value will become true, that means whenever we are going to implement the set method, automatically internal flag will become what? True. Then your threads can execute the particular method or a function. Next, if you're going to consider clear means what? Internal flag will set to what? False. Automatically whatever the threads that are going to execute, automatically those are going to be stopped on that particular event object. So what is the use of this wait? So by using this wait, thread can wait until some event occurs. Okay, that event is set. Okay, until event is set, threads are going to be waited. Next, what is the use of this isSet? isSet is a method to check whether the set is enabled or disabled. Okay, if set is enabled, then automatically it is going to return what? True. If set is false, if set is not enabled, then automatically it is going to give you what? False. So now in today's session, we are going to see about condition and queue classes. So what is the use of this condition means? Here also same. So in yesterday's session, to implement the inter-thread communication, we have created the object of event. In today's session, we are going to create the object of condition, and also in next we are going to see about queue object also. Right. Now first I will explain about condition class. Okay. So now observe here. Let us see about condition class. So condition. So here we have to create an object initially. So internally, this condition object is associated with lock concept. That is nothing but R lock. It is associated with a R lock. That means here we can say what? Synchronization is also can be applicable here. Internally one lock is there. Which lock? It is not a normal lock. It is a R lock, reentrant lock we are having here. Okay. So what is meant by this condition means? So when compared to event, this is somewhat advanced version of event. Okay. Right. So generally what this condition is going to represent means is it represents some state change in an application. Okay, let us see with a small example. Okay, if I'm going to consider this one as some condition. Okay, so here whenever someone is going to use this one, okay, then what is meant by this condition means it is some state change. So let us consider here producer is there, here consumer is there. If the producer is going to produce an item, it is nothing what initially the condition is different. Now it is going to change its state. Okay, next let us consider here some value is there, and next time consumer is going to consume this item. That means what? The state of this is going to be changed. Okay, That means the state, it indicates what? The state of the, sorry, the state change. Condition is going to represent what? Some state change, right? So here, what is the main thing? Generally, at a time only one has to execute this particular buffer, for example. So if, let us consider, if one thread is going to execute on this condition, okay, on this condition, then automatically remaining threads has to do what? Remaining thread has to wait. So why, let us consider consumer is waiting for this condition. Why it has to wait? So threads can wait. For example, I'm telling threads can wait for this condition, and threads can notify once the condition happened. That means what? Here, let us consider producer is there. When notification will be sent to consumer? Once, if the state is going to be changed by this producer, then there is a need of notification to this consumer, so that this consumer will do what? Consumer is going to acquire that data. Okay, right. Now here concept is what? Condition object. That means what can I say here? Condition objects allows one or more threads to wait until notified by another thread. Let us consider here I have taken only one thread. If I take some X thread also, here P can notify to both the threads, there is no problem. Multiple threads can be waited, can wait on this condition object. Okay, right. Mainly here we are going to use the concept of mainly two methods. One is acquire method. Okay, condition has what? Acquire method and release methods. For what we are going to have this one? It is going to call the corresponding methods of the associated log. These are going to be used for what? These are going to be used for acquire the log and release the log. Okay, this is the concept. So how to create an object of this condition? So just C equal to condition, right? So and also here we are having some more methods we are going to use with this condition. Those are wait. In yesterday's session for the event also we have seen this wait. So wait, or we can consider what? Wait of some time also I can give for this one. Next we are having one more or two more methods. There are notify and notify all. So already you know what is the use of this acquire and release. Already you know what is the need of this wait. So once again I'm repeating about briefly about this concept. So acquire means what? Why we are going to use this acquire method? To acquire condition object. Here the thing is what? In before example log concept, what we have applied? For acquiring the log we have used this acquire method. Now for what I'm going to use? To acquire a condition object. To acquire a, for example, this is a condition object I'm going to consider. So to acquire this condition object by this thread, by this producer thread, I can use the concept of acquire. After acquiring the condition object, what we can do? We can use that condition object. Okay, that is to acquire condition object. For I'm going to consider about this producer and consumer problem. To acquire condition object before producing our consumer items, we have to acquire what? Log. So why I am saying here log? Because internally for the condition object we are going to have what? One log, which is nothing but a reentrant log. That is nothing but R log. So that we have to log, we have to hold this one, we have to acquire this one, then only we have to produce. Otherwise, if consumer want to use this one, first he has to apply which log? Sorry, which one? Acquire. After that only he can consume. So before going to produce or before going to consume, we have to apply which method on this condition? Acquire method. Without acquiring method, I cannot use this condition. Right. Now let us see about release. So to release the condition, that means what? Already here, for example, producer is going to acquire the condition. So after producing, what this producer has to do? Producer has to release that one. So after completing the use of this condition by the producer, it is going to apply what? It is going to apply release, which is nothing but we can say what? Thread release as the internal log, because internally we are having what? Log concept is there for this condition. Right. Next, what is the use of this wait? To wait until, this is used for what? To make threads to wait until what? Until it gets the notification. So whenever excuse. Whenever here I'm going to say one small example, producer is going to produce. Okay, then automatically this consumer has to do what? Consumer has to wait on this condition. So what it will apply? See, for example, I'm going to take condition dot. This is a condition object, for example, condition dot wait. Okay, because condition is held by is using by whom? Producer. So consumer is going to wait on this condition. Once this producer produces the data into this buffer, for example, then after completing the production, what it has to give? It has to give notification. Notify method it has to apply, so that as this thread is in waiting state, it will come back to running state and it will consume the data from this. Sorry, it will hold the, or it will acquire the condition object, and it is going to use that condition object for consuming purpose. Okay, so this is for what? How much time you have to wait. Otherwise, if you apply wait, it will wait for notification receiving. Until the notification receives, it is not going to use that condition object. It will be in waiting state only. Next, what is meant by notification? So here I have to tell something to the consumer, because it is waiting. Someone has to tell. It is waiting for what? It is waiting for this condition. So this condition is used for what? Used by whom? Producer. So after producer is completing its task by the condition, it has to intimate to the consumer. So already yesterday I have given a small example. Here inside doctor is there, outside patients are there. Patient 1, patient 2, patient 3. Already internally one more patient is there, patient 4 is there, for example. So after he is going to see this patient, he will go away. For example, patient 4 is completed his appointment with the doctor. So what he has to do? This compounder has to tell. This compounder has to tell to this, notify to this patient 1. Then what patient 1 will do? Patient 1 will use this doctor. Okay. Next, after P1 is going to complete, someone has to intimate, someone has to give the notifications. Okay. So in this case, producer is going to produce after completing the task of production. Sorry, producer. Then producer has to notify, so that other threads who is waiting on this condition will understand that, okay, can access this condition object. So this is the concept of condition. Sorry, notify. Now notify all. What is meant by notify all? Generally, I told you what this on this condition object, multiple threads can be wait. Multiple threads can wait here. So if I want to intimate to only particular thread, I have to apply notify. But if I want to apply, if I want to notify to all the threads which are waiting on this for this condition, I have to apply what? Notify all. Notify means only to a particular thread. Notify all means all the threads, the waiting threads which are waiting for this condition object, the notification will be sent. Once the notification is received by the waiting threads, then they can use that condition. So who will get the chance to access that condition? Those who, it is based on our algorithm which is used. Okay, right. This is about the concept of notify all. So these are the 5 methods we will use. One is what? Acquire, release. Mainly these are for what? The lock purpose. Okay, after that we are going to use wait, and also we can provide the some time also. Next, notify all. Right, now let us go to one small example here. When to apply which method? Let us see now. So generally what happens? One thread is going to, I will take generally for all this inter-thread communication, I will take only the concept of producer and consumer. Okay, here I am going to take producer thread, and here I am going to take consumer thread. Now the producer thread is going to produce, needs so he want to produce something, so he has to acquire what? He has to acquire that condition object, before going to produce. So now let us consider this producer has uh, taken the condition, that is what C dot acquire, it is going to write. That means what? C is acquired by this producer. So after that he can use what? He can use this condition object and he can produce. After producing the item, then what it has to do? It has to give the notifications to the consumers. So once again I'm repeating. So the producer thread needs to acquire the condition object before going to produce the items. Okay, and what it has to do after completing the production, it has to give the notifications to the consumer. Why it has to give the notification to the consumer? Because consumer is waiting for it. So until what time consumer has to wait? Until consumer gets the notification, consumer has to wait. Who will give the notification? Notification will be given by producer. If producer is not going to give the notification, then consumer will wait for long time. That can I say infinite time. So if any thread is going to wait for infinite time, then it will enter into deadlock state. Okay, right. Anyway, now okay, the scenario is what next? After producer is going to use the notify method, then consumer will come to running state and it is going to acquire this condition object by using c.acquire here. Okay, now so it will do what? It will consume the data from this buffer, for example. So after completing, what again producer will do? What producer will produce, and so on. The process will be continued. Just I am going to show you a small scenario. Producer will do what? Producer is going to produce items, and sorry, first initially before going to produce the items, it has to do what? It has to acquire. It has to acquire the condition object, and it has to do what? It has to produce the items. After producing the items, what it has to do? It has to notify c.notify, so that those who are waiting for this condition object, for those threads the notification, sorry, only for a particular thread notification will be sent. Okay, after that it will release. As it is acquiring, it will be released. So see the steps. Producer is going to acquire the log, produce the items, next giving the notification after releasing the condition object. Now let us talk about consumer. So before going to consume the data, what consumer should have? Consumer should acquire the condition object. Okay, and it can consume the items from this buffer, for example. Now let us write the thing. So it is going to do what? First it is going to acquire the condition object, and let us take here, for example, I will write c.wait. I am going to write here. Why I am going to write this one, I will explain it. Because first let us consider consumer came to this buffer before going to produce the items by the producer. Consumer came. So what it has to do? See, it will acquire the log, and as there is no items, it will do what? It will wait. It will wait on that condition object. Then whenever C is going this thread is going to waiting state, then automatically lock will be released. Then producer can acquire that lock. There is no problem. Okay, once again I am repeating. So if consumer comes to execute the code before producer enters, then what happens? Producer will acquire the lock, and consumer will see that if there are no items, what consumer has to do? It has to wait for that condition object. So it will wait for condition object. When the consumer thread is going to wait state, it will release that lock. Whatever it has acquired, it will release that. There is no problem. So next, whenever the notification is going to be given, that means what? If this condition is not set, so if it is not waiting, then what it has to do? What has to be done? It is going to consume the item. If it is not waiting, I am telling. Okay, consume the item, and after consuming the item, as it is going to acquire, it is going to release that. It is going to release. Who will wait? Who will wait? Those who needs updations. Who needs updations? Those are going to wait. Those who are going to update, they will apply what? They are going to apply notify method. Right. This is the concept of condition object. Now the same scenario, I am going to use this in our program. Okay, same producer and consumer program I am going to write here. So here, which one I have to take? From which module I am going to take all these things? From threading module. From threading module, I require all the classes. So I will write what? From threading import all. So already I told you, whenever we are seeing the concept of multi-threading, better use the time so that you can observe the variations. So that I'm going to write what? Import time. So in this, what I want to do? I want to produce the items. I want to produce what? Items. For that, I am going to import random module. Already we have seen about this random module in previous sessions. So by using this random module, in this we are having some methods. So by using those methods, I am going to generate different values. Okay, right. So first I want to talk about a producer thread or produce method. Produce method I want to talk about. So in this produce method, I have to pass a condition object. Okay, so I will discuss once again after completing this code. So right, what it has to do, it has to produce. So first I will write what? While condition, while of true. In yesterday's case also we have taken while of true. It will be execute so on until we stop. So what it has to do? Producer has to do what? It has to acquire condition. So before going to acquire the condition, I have to create a condition object. So that I will create here. Okay, C equal to condition. I'm going to create C equal to condition. That means condition object is going to be created here. Now I want to acquire that. Before going to produce the items, I have to acquire what? Condition object. So I'm going to acquire that. Now after acquiring, what I have to do? I can produce the items. So I can produce the items into your buffer. So first I want to take the items. For that I'm going to use random module. I'm going to use, that is random dot. Already we know how to generate integers. Random dot randint. So I want to generate a random numbers between, for example, I want to take from 1 to 20. I'm going to take the random numbers are going to be generated and it is going to store in some item. Okay, here I want to take the value for this item. So I have not yet used. What is this item? I have to specify it. So let us take items as, let us take items as a list, So items equal to, I will write empty list here. Okay, right. So now here what happens? Items is going to be generated for every iteration. Only item will be generated. So I will take only item here. Okay, let us see. So random number is going to be generated here. After that, I want to produce this item. That means I want to insert this item. So what I will write, just for our understanding purpose, I'm going to write producer, producing item. So which thread is going to execute this produce method? Producer thread. Let us consider T1. T1 is going to execute that. So producing item. Which item it will produce? Already I have taken in a item. So it is going to produce item, whatever it is going to be generated randomly. After that, whatever the item we got. Sorry, here I have taken only one item. So I will make it as items, because whatever the item here I have taken, I want to store it in a buffer. Already I told you. So here in the place of buffer, I have taken what? I have taken the concept of list. Now see, items dot append, of item. That means whatever the item I have generated here, I am storing in a buffer. Here buffer is nothing but what? I have taken one list. So producer is going to take an item, take a value, and it is going to store in a items. So what consumer has to do? After production is completed by the producer, he has to consume the data from the items. That is the concept. Now after this, okay, I have produced the item into the list. Now production is completed. I have to give notification to whom? I have to give the notification. So giving the notification, I have written what? Giving the notification. So before going to give the notification, just I have intimated for the user. So for our understanding purpose only, for increasing the readability, I have written these statements. So which method I have to use? C dot notify. Now what happens? Notify method is going to, if I apply notify on this C, automatically the threads which are waiting for this condition object can acquire the condition object. Now see, after that I'm going to do what? C dot release. Completed. This is the concept of production. So after production, what I have to see? I have to observe the case. After production, what is going to be happen? So that I am going to, that means what? For every item production, I'm going to take some time. So that I will take 5 seconds. I will take 5 seconds. Right. Now this is about produce method, which is going to be used by one thread. Let us take T1. Okay. Right. Now I want to talk about consume method. Consume method. So here also I'm going to pass what? Condition object only. See this condition object only. Right. Now observe carefully. Here what I have to do? Here also it is go on producing while of true. Here also I will take what? While of true. While true. That means it will execute infinite time. There is no problem. So what I have to do? I have to acquire the lock first. First I have to acquire. Next, if the thread comes before the producer thread, then it has to do what? It has to wait generally. Okay. So c dot wait. On c it is going to wait. So how we have to do that? So just I'm going to tell clearly that our thread is going to wait for, so what can I say? Consumer, I can say. Consumer is waiting. Why it is waiting? To get the data. To get the data. Waiting for updation. I can say waiting for updations. Right. So that it is going to wait. Now what happens? Consumer is going to consume the data. If it is not going to wait, that means what? It is waiting. This particular consumer thread is going to wait here. Once the notification is given by this producer, it will go into what? It can execute the remaining code. It can acquire, and it can already is acquired here. So it can do what? It can execute the remaining code. That is nothing but it can consume the data. So what can I write here? Consumer or consuming data, I can write here. Consuming data. From where the data is inserted, or consuming item. I have used their item. So here consuming item. Which item? Already I have inserted the items into items list. So that what I have to do here, just I am going to write items dot pop. Already we know what is the use of pop. Okay. Right. Now it is going to take the data. It is going to return the value, and it is going to remove from that list. So after that my task is completed. I am going to release condition object, and here also I will give for understanding purpose I am going to write time of sleep of 2. I will write. I will not take more 5 seconds. Just I will take 2 seconds, so that you can observe clearly. It is going to produce. It is going to consume. It is going to produce. It is going to consume, and so on. We have to observe this type of scenario. Okay. Right. Now observe. Now already here condition object is created. What I have to do? I have to create the threads. So just I will create 2 threads. T1 equal to thread. What should be the target thread? For example, first thread I am going to give target as consume. Okay, or I can give anything. There is no problem. Let us take consume. I will take consume here. So what is the arguments I have to pass? Condition object. Okay, condition object I have to pass. So args equal to, just I will pass what? Condition object. There is nothing but C. Right. I have passed C. In the same way, for thread 2 also, I am going to pass some arguments. That is what? Same condition object I am going to pass. And here target will be what? Here target will be produce. Target will be produce. So the name of thread is what? Object reference is what? T2. So after creating a thread, what we have to do? We have to start them. So T1 dot start. And after that we can write T2 dot start. Okay, right. Okay, see here in this program what we have created. Two threads I have created. For T1, there is a thread 1. I am going to give the target as what? Consume. So thread 1 is going to execute this one. Thread 2 is going to execute target produce. So I want to start thread 1 now. Okay, you can start produce also, there is no problem. But I want to show you that consumer thread is going to wait for production. So that I am going to start which one? T1 dot start. That means first which is going to be executed? Consume. While T1 is executing this one, T2 goes here. Okay. Now first C dot acquire. C dot acquire means what? Thread 1 is going to acquire. And when this T2 goes here, what happens? Already it is acquired by the consumer. So it has to wait here. Okay. It is not having. So that what happens here? Again, consumer is waiting for updations will be printed. After that, C dot wait. Now this thread is going to wait. Whenever one thread is going to wait, the lock will be released on that particular C. The C will be released because it's waiting on C. It is telling what? I will wait for C. So that C can be taken by other thread. So now it will take that, it will acquire, and it's going to generate one random number, and it will produce that, and we are going to print that, and we are going to store in items like a buffer. Items acts as what here? Like a buffer. So giving the notification, no, giving the notification C dot notify. So whenever this notify is going to be applied, and it's going to release that lock also. So here it is waiting for that, waiting for what? Condition. So it is released here, and it is notified, it is released here, so that this consumer thread can execute what? Consuming item, which is nothing but items dot pop. That means that already some items are there in these items that will be popped. Popped is nothing but whatever the item that is produced here, that is going to be popped by this consumer. So the task of consumer is completed. So it's going to apply what? C dot release. Okay. Now observe here. So just I will change some more time here, because sometimes what happens here, if I'm going to produce the item here, before going to consume, once again the while loop may be run here, so that I will increase the time, so that you will get a clarity. So there will be no confusion here. Now observe. So producing item. So consumer is waiting for updations. Okay. Producing item 2, giving the notification, consume the item. Next, consumer is waiting for updations. Okay. Producing item 12, giving the notification, consuming item 12. Consumer waiting for updations. Producing item 7, giving the notification, consumer is consuming the items. So by using the concept of condition, we can implement the concept of inter-thread communication in this way. Okay. See, production, consuming, producing, consuming, producing, consuming. That means what here? There is a communication between two threads here. Okay, so that until producer is going to produce, consumer is not going to consume. In such a way, we have written the program here. Right. Now this is the concept of what? Condition class, or we can say condition object. So in the above program, what we have to observe? In the above program, consumer thread is expecting updation. Consumer thread is expecting what? Updation. So that here what we are going to do? We are going to use the concept of wait. Okay, wait on what? That particular condition. Producer is going to what? It is going to perform updations. There is nothing but it is going to insert the data, and it has to do what? It has to apply notify method. So this is about the concept of condition class, and we have seen how to implement inter-thread communication by using this condition object. Now let us go to next one. That is nothing but queue. This is a very enhanced, this is very, what we can say, when we compare event, when we are going to compare event and this condition is more advanced version than event. In the same way, if you are going to consider event and condition, this queue concept is more enhanced mechanism. Okay, it is what? More enhanced mechanism. Right. Now let us see the concept of queue. So how we are going to implement the concept of inter-thread communication by using the concept of queue class. So here a very important point we have to see here. This queue is going to provide what? Abstraction. That means what? No need of using all the methods. Internally it is going to do all the things. Just we are going to use basic methods, put and get. That's it. Internally everything will be done by this queue. Let us see the concept. So this queue internally has condition. That means what? Condition is available inside this queue. So in condition, what we have? This condition will have what? And condition will have lock. Already we know this. We have seen this concept. And condition has lock. So that means what here? As we are having lock here, what we can say? So we are not required to worry about that synchronization, as we are having log in this case, and condition case also we should not worry about the concept of synchronization. So as we have seen about event and condition, to use event concept and condition concept, first we have to do what? we have to create an object. Here also we have to create an object, but first we have to see that where this queue is present. Queue is not present in threading module. It is present inside a module called as queue module. Okay, that means I have to import this queue module. After that I have to create an object for that queue, and I have to use the concept of put and get. Okay, right. First what we have to do, first this is the first step. First we have to import queue. After that object has to be created. How object should be created? Just object reference, and we have to write the class name. What is the class name here? Queue is the class name. Okay, right. So if I write here import queue, I have to write what? Queue.queue. Otherwise what I have to write here? From, if I write from queue import all, then directly we can write only queue class. Okay, right. Here we are going to use mainly two methods. The methods used for this queue are, first one is put. First one is what? Put. Second one is get. So why this is used? For putting an item, for putting an item into the queue. So here the name is queue. So insertion will be there, deletion will be there. By using this put, I can insert the data into the queue. Next, get means what? I am going to get the data from the queue. That is nothing but I can say, it, already we have seen pop method in before example. In the same way here, the item is going to be returned and it is going to be removed. It is going to be removed. It is going to be removed. So put method is for what? To insert the data into the queue. Get method is for what? It is going to get the data of the queue and it is going to delete that item. Okay, right. Here the same scenario I will consider. What is that scenario? The scenario is producer and consumer. Here producer, here consumer. What producer thread will do? It will use a method called as put method. What is the use of this put method? So put method is used to insert the data. So it is inserting the data. Next, very important point I want to discuss here. Internally, already I told you, queue is having what? A condition, and condition internally is having what? A lock concept. So now for this put method, internally it is having the concept of acquiring the lock. Okay, inside it is having, as it is having condition and it is having lock concept. Whenever I am going to use the concept of put method, internally what happens? Internally acquire method is going to be executed. That means what? It's going to acquire the lock, and after that only the data will be inserted. That, but we cannot see all those concepts. Internally it will be done. Okay, that means what? It is going to provide an abstract things for us, so which is recommended, because no need of using all these acquire, release every time. Just if you use put, then automatically data will be inserted. Internally what is going to be happen? Lock is going to be acquired by this producer and the data is going to be inserted. Okay, no need of using this acquire method externally, as we have seen for condition. Okay, right. After inserting, so after inserting the data by the producer, what has to be done? The data lock will be released automatically. If the task is completed, automatically it is going to be released. Am I acquired? No, internally it is acquired. If the task is completed, automatically it is going to be released. So once again I am repeating, whenever I am going to apply put, first internally it is going to acquire the lock. After that, data is going to be inserted. After data is going to be inserted, it is going to apply a release method internally and automatically. There is no need of doing externally all these things. Okay, right. And also here the advantage is what? Put method also checks whether this queue is full or not. It will check everything. So whether the queue is full or not. If the queue is full, will it produce? If queue is full, then producer thread will enter into the waiting state. This is very important concept. You have to understand clearly. That is what put method is going to do. Initially it is going to acquire the lock and it is going to insert the data, and after that, after completing the insertion, it is going to do what? Internally it is going to release the lock. Now the one more concept is going to check is, so it is going to produce the items onto this queue if once the queue is filled, automatically it has to apply what? It will apply wait method. It is going to apply what? Wait method. When this producer is going to apply a wait method, if the queue is full, then the producer thread will enter into a waiting state by calling which method? Wait method. Internally, it is going to be done. Externally, no need of calling anything. This is going to be done internally. This is going to be done internally, and these three methods are going to be done internally. Just I am going to use what? Only put method. So here, just I will briefly summarize this put method. That is what? If we are going to apply a put method, first what happens? Internally, it is going to apply it is going to implement acquire method. After that, we are going to insert the data. After inserting the data, it is going to release the log, and in between it is going to check what? Whether this queue is full or not. If the queue is filled, automatically it is going to enter into a waiting state. I am not going to apply anything. Internally, wait method is going to be applied. This is about put. Now I want to talk about get. I want to talk about what? Get method. So who is going to apply get method? Consumer is going to apply a get method. So whenever consumer is going to apply a get method, what happens? The data will be removed from this queue. The data will be removed from this queue, and internally what happens? Before going to remove the object, it is also applying what? Acquire method, and it will consume the data. After consuming, it is going to use what? It is going to use the concept of release. Okay, it is going to use the concept of release. Next, once after releasing, what happens? The task is completed, and here also one condition I have to check. Internally, the one condition is going to be checked. That is, while this process is going on, if I try to consume a queue, if I am trying to consume a data from the queue, and if the queue is empty, can I take anything from the queue? No, it is not possible. So that if this queue is empty, automatically the thread is going to enter into what? Waiting state. It is no need of applying this wait method externally, and no need of writing the conditions also here. Automatically it will enter into what? Waiting state. Okay, then what happens? If so, as it is entering into the waiting state, then when it will give the notification, when it will get the notification, once if put is going to be executed, internally the notification will be sent to this particular thread, waiting thread. Okay, this is the concept. Next, here one point we have to understand, that here the queue module take care of locking. Okay, who is going to take? Queue module is going to take care of locking, right? This is about how put and get is going to be worked internally. Once again, briefly I will give you the about put and get methods. Put means what happens? Here some queue will be created. What happens? Queue is going to be, let us say I have created a queue. So whenever I am going to apply, let us take producer is going to apply a put method. Here I will take consumer. Consumer will apply what? Get method. So what are the things that has to be happen? Tell me first. First thing is what? First thing will be, before going to do this one, it has to acquire that. Let us take this one as a queue, for example. Queue dot acquire. Who is going to apply this one? Internally, it is going to be applied. Next, after that, second step is what? Second step will be produce the data. Produce the data or produce the item. After producing the item, what has to be done? It has to be, queue has to be released. Am I doing all these things externally? No, I'm not going to do everything. Internally, all these are going to be done automatically. Okay, next, after releasing, okay, now we have to check one more thing. That is what? Here itself, whenever I'm producing the data, if the queue is full, automatically I'm not applying. Internally, it is the logic is going to be implemented for wait. So it will this thread is going to enter into what? Wait. When it is going to enter into wait, if the queue is full. Next, come to consumer. So whenever the, okay, after production, it will get the notification. Consumer will get the notification. Finally, what happens? Notification will be given. So here only notification will be given. So here I will write notification. After that, come to consumer. So before going to consumer, it has to internally get method is going to implement what? Acquire method. After acquiring that queue only, it is going to consume the data. After that, it is going to release. And here also one logic is going to be implemented. That is what? Whenever the queue is going to be empty, consumer will enter into what? Waiting state. Consumer will enter into waiting state. So when it will come back from the waiting state, once notification is received, then it will come back to execution state. Okay, and it will consume the items that are in the queue. Right, now let us see this concept in a programmatic way. Okay, now see, just I will remove this one. So anyway, from threading is common. From threading import all, import star indicates all. So here I am using the concept of queue so that I will import what? Otherwise here also I will write from queue import all. Otherwise I can write import queue, and every time I have to use this module name, so that I have written this one. Anyway, here also I am going to import random. So as I am using only once or twice random, I am going to import it. Next, after that I have to import what? Time also I will import here. So these are the 4 modules I am going to use here. The concept is same. Here I have to write what? Produce function I have to write, and I'm going to take which object I have to take? Queue. Right, now item equal to what? Item I am going to generate here. Random I am going to generate here. Random. So random number I want to use. So random int I want to set. Sorry, from random I have to use random int. From which to which numbers I want to select? I can take any numbers. There is no problem. I am taking 1 to 20. So same scenario. Print off. I will take print off. Producing the item. So where that item is? Inside the item. So here I am going to write what? Just I will print item. So that item is going to be printed. So I want to, if it is going to produce that item, it has to be placed in where? Inside a queue. So I will write what? Queue dot put. When I write this statement, internally what happens? First it will acquire the lock on queue, and it will produce the data, and after producing the data, it is going to release that queue. Okay, in between what happens? If the queue is full, this particular thread is going to enter into a waiting state. Internally this logic also is going to be implemented. Right, queue dot put. After that, producer has to give notification. So just I'm going to write produce notification is giving. Otherwise producer is giving notification. Okay, right, this is the scenario here. So as it is telling, it is going to give notification. That means I will not give anything. Internally it will be done. Okay, so just for our purpose I'm going to write this statement. So here just I will write some time dot sleep of 7. More time I will take here. Right, this is about production. Next, let us take consume method, consume function. So consume of on queue, where we are going to produce on queue only. So I'm going to use as parameter as queue here. So while true I am going to write. While true, what I have to do? I have to consume the data. So first, before going to consume, as product produced is going to use this queue, so here it has to wait. How we will know it? Internally queue is going to implement all these things. There is no problem. So consumer waiting for updations. Okay, right. After that, automatically after inserting the data here, what happens? It will give the notification for this automatically. So just directly I will write what? So consumer consuming I will write consuming what? Whatever the data it is produced, I am going to consume. As I have used their put, here I have to use what? Get. Okay, consuming, here I will write producing the item, the number will be printed. Here I will write what? Consuming the item. Consuming the item I have written here. So what I have to write here? Item. Sorry, what I have to write? Q dot. Q dot. Here I have inserting, so that I have used what? Put. Here I am going to get it. So I have to use Q dot get. So here also for every time I am going to use the concept of time dot sleep. Time dot sleep of, just here I will write 5. So it has to be executed for every time. Okay, here I have not taken while loop, sorry. Here also I will take what? While true. So it will run for ever. So for I have to give indentation here. Okay. So it is going to be produced, so on. It is going to produce, it is consumer is going to consume. For this I have to create what? I have to create queue object. For that I'm going to write q equal to, it is not compulsory to write always small q or small c or small e. We can write any name, but generally if I am using q, I'm going to use small q. If I'm going to use event, I will use small e. If I'm going to use the concept of condition, I will write small c. Right, now I want to create what? Two threads. So thread equal to, sorry, t1 equal to thread, and here target is what? First I will write target equal to, for thread 1 I'm going to write target equal to consume. Target equal to what? Consume. So I want to pass argument as what? Q I have to pass. Argument as Q. Q I am going to write here. Next same thing I will apply it to the T2 also, thread 2 also. Because the concept is same. I am going to create two threads, but for second thread what I am going to give? Arguments as Q, but target as what? Produce. Target as produce. So that it is going to execute what? Produce function. So T1 will execute consume and T2 is going to execute produce. So after creating the threads, what I have to do? T1 dot start, and after that I can write T2 dot start. So this is the case. Just I'm going to execute the program. There is no much thing to explain here, because whatever the things that we have executed before in condition, all those things are going to be done implicitly. No wait is using here, no notification is using here, no acquire is using, no release is using here, because everything is going to be implemented automatically internally whenever we are going to use the queue. So whenever we are going to use q dot put, internally what are the things that are going to be executed? One is, first thing is what? Acquiring log, producing the data, after producing the data, releasing the log. In between this, so what it is going to check? Whether the buffer is full or not. If it is full, it is going to waiting state. If it is not full, it is going to produce. But here I am producing only minimum content, so one value only, so that it will not be full, so that I am not going to show you about waiting here. So consumer is waiting here. By default, whenever other thread is using put method, it will enter into what? It will enter into waiting state. So after, so that it will enter into waiting state. After the production is completed, what happens automatically? Consumer is going to consume that item by using a q dot get. Same here also, what happens? Acquiring the log, consume the data, release the log. In between, if producer is not going to produce anything, it cannot consume anything. It will enter into what? Waiting state. Now observe this case. So here, 1 minute, produce is not defined. Sorry, here I have written E. Okay. Now let us see. So once again, random has no attribute random int. So here randint, sorry, it is what? Randint, not random int. Right. So here now you can observe, 1 minute. So I want to execute this program now. 1 minute, please. So my program is on desktop. So I have to execute what? Python space test.py. Now again, one more thing is there. Put missing one required argument. So put is going to receive one thing, right? Sorry. Here whenever I'm going to put, I have to pass something. So I have to pass some item here. So I have not passed it. Now let us see. So now see, producer producing the item, producer is giving notification, consuming the item. Again, consumer is waiting for updations, producing the item 20, producer is giving notification, consumer is consuming the item, and so on and so on. It's go on continuing. Okay. So in this way, I can implement the concept of what? Interthread communication by using queue. So here, one more small topic I have to discuss about this queue. That is, here just I have discussed only about normal queue, but here we are going to have in this queue, it is having three types. It is going to have. First one is FIFO queue. That means if I want to use FIFO queue, I can use. Concept will be same. Okay, FIFO queue is nothing but what? Whatever the element that is going to be used, that has to be get out first. That means what? First in, first out. First in, first out. So generally, queue is nothing but first in, first out only. That means whatever the data I have executed till whatever the program I have executed, by default it will use queue only. So that I will show you once again whether it is giving first in or first out by taking a few numbers. Okay. After that, I want to implement LifoQueue. That means what? Additionally, one more class I require here. For that, I am having a class called as LifoQueue. LifoQueue, capital L. Okay, LIFO. Right. Next, third one is based on the priority. If I want to retrieve the values, for that I am going to the concept of which queue? PriorityQueue. So for this, we are having a class called as PriorityQueue class. PriorityQueue. Okay, this is the class name. So here queue class, here LiFo, here LifoQueue, here PriorityQueue. So already whatever the example we have seen, that follows what? First in, first out. That is nothing but by default, our queue is going to have which nature? First in, first out. That means what? In whatever the order we are going to insert or we are going to put the items in the queue, in the same order it is going to retrieve the objects. That is nothing but first in, first out. So already here I have taken a random number so that it is going to produce, it is going to take. But I want to show you now, I want to show that here it is going to take in a first in, first out order. Okay, just I am going to use a small case here. Just I don't want to implement the concept of what we can say threads. Just I want to show you that first in, first out queue is going to take the data, whatever the data it is going to take first, it is going to be printed first. So just I have to create what? No need of this threading module also, because now I am not talking about this concept of threads here. So the concept of threads is completed. Just I want to use the concept of queue. That means different flavors of queue I am going to show you now. So in the place of, in before example, in the place of queue, we can also place what? Last in, first out queue, or we can also use PriorityQueue. So I'll explain the concept of first queue. So I'm going to create a queue here. Okay. I'm going to create a small queue equal to queue object I am going to create. Okay, queue object is created, and I want to insert them. Just by using what? Put, I can use that. So here which thread is going to execute? Main thread is going to execute internally. So just I want to insert some values here. So queue dot put, here I want to show you what? Whatever the data we are going to insert first, it is going to be retrieved first. That I want to show you. 10, 20, I will write some more values. 30, 40 I will write. Okay. So I have inserted some data here. Some 4 elements I have inserted. What should be, if I apply get, what should be the output of first value? First value should be 10, second value should be 20, third value should be 30, fourth value should be 40, because in the same order I have inserted. What is the first element inserted? 10. So what is the first element is going to be given out? That is nothing but 10 only. Right. Just I will write a while loop here. Just I will write what? While loop, and there is one empty method is there in queue. What is that method name? Empty. So it will check what? Whether the queue is empty or not. If the queue is empty, it is going to return false. Okay, it is going to return true. I am asking whether the queue is empty or not. If it says true, That means while not true is nothing but what? False. Okay, whenever it is empty, automatically will come out of this loop. If it is false, I am going to get what? If it is not empty, I want to print all the elements. Okay, so for printing, what I have to use? Print off. Print off. I will print q dot get. So now you can see what? Just whatever the order we have inserted, in the same order output is going to be printed. See, 10, 20, 30, 40. Here what we have to observe? First in, first out nature is there for your queue. Default nature is what? First in, first out. Now the concept is, I don't want to follow this first in, first out nature. So just I want to follow last in, first out. Then just use the concept of LifoQueue. LifoQueue is nothing but last in, first out queue. So whatever the value you are inserting last, it will be printed out first. There is nothing but what? Last inserted, it will be inserted first. Last in, first out. This is inserted last. So it will be given as first output. That means the answer of this program will be what? 40, 30, 20 and 10. Let us see the output. See, 40, 30, 20 and 10. So this is about LifoQueue. Next, third one is what? Third type of queue is what? Priority queue. What is meant by priority queue? See here, for every element, some priority will be given. For every element, some priority will be given. So if you observe here, if you observe the these programs here, what we are going to observe? First in, first out and last in, first out. But now I want to implement what? Priority queue. Priority priority queue. Just I will execute. After that, I will tell you what is meant by priority queue. So what it is giving? 10, 20, 30, 40. You may think that, sir, these two are acting as same. Queue and priority queue is acting as same. No. Just I will change the values so that you can understand clearly. 10, 5, 3. Here I will write 9. Okay. Otherwise, okay. Here I will write what? 9. And here I will write 3. Observe the output now. So what is the output we are going to get? 3, 5, 9, 10. That means here for a numbers, I have not given any priorities. By default, internally what happens means the lowest number will have highest priority, so that in order it is going to print. So among these, which is having highest priority? 3, next 5, next 9, next 10. So if I'm not going to give any priority, by default it is going to take lowest number as highest priority, and it is going to print according to the order. So that is nothing but what? 3, 5, 9, 10 is going to be printed. So now I want to show you an example. So as for the numbers, you have understood clearly, but I want to take some names. And I want to give the priorities to them, and I want to show you. Okay, as names, as numbers you have seen here. Just I will give you here some. First, I will give you alphabetical, some alphabets. I will give some names. I will give. Shiva I have given, and after that I am giving Rama, and here I am going to give Prasad, and here I am going to give some Kollu. Okay, now observe the scenario. So what happens? It is printing Shiva, Kollu, Prasad, Rama. Why it is going to print in that way? You may confuse here. Okay, I will not make you confuse, because here I have written capital S. So capital S is having lowest value internally. Internally for capital S, what happens? Lowest Unicode will be there. So it is printed first. After that, small k. After that, small p. So that I will not make you confuse. Just I will take small s. Now which one has to be printed first? Okay, you have to observe that. Which one is going to become first? K. After K, L, M, N, O, P. P will be printed. After that, Q, R. After that, S. It is not a reverse order. Just I will take in between, so that you will get a clarity on this. Here I am going to write small s only. See, here I am going to 1 minute. Here I will take Prasad. Here I said I will combine the words. So here I will take Rama. I will take, and here I will take some Kollu. I will take here. Okay. So here I will take Shiva. Now you can observe. First, what will be printed? Kollu will be printed. After that, after K what? L, M, N, O, P. P will be printed. Prasad will be printed. After that, Rama will be printed. After that, Shiva will be printed. So based on the order only, it is going to print. See, K, P, R, S. Okay, according to the order, alphabetical order, it is going to print. If you are not going to give any priorities for these strings, internally it is going to use by default alphabetical order it is going to use. Now the concept is I want to give the priorities. As it is in different order, I don't mind, but what first it has to be printed. I want to print first Shiva, after that Rama, after that Prasad, after that Kollu I want to print, so that I'm giving what priorities to them. So whenever get is going to be implemented, what happens here? It is going to use the concept of will check the priorities. So based on the priorities we have given, it is going to print the values. Let us see now what happens. So see what happens. Oh, sorry. Here it is going to print whatever the priorities we have given, it is going to print. But I want what these values. So just here I want to change that. That what I have to print, I want to print indexes are what here. This is 0 and this is going to be considered as 1. So while printing, I want to print first element. That is nothing but I want to print the names. Okay. I want to print what? Names. So just I will print the names. Observe now. 1 minute. Int object is not subscriptable. Here one thing we have to observe. What we are going to write here. Q dot get I am going to write, and I am going to write 1 here. Yes. After, yes, it is correct. Okay. Here it can be taken because I want to print this one. So it will take what? It will take entire thing and it is going to print the output as this. I want to print the values. So I am going to check 1 minute. Okay, priority queue I have taken, putting the values, and I have given the priorities also here. So based on the priorities, I want to get the output. So I want to print what? I don't want to print the 0th index. I want to print it first index. So let us see what happens here. Why it is going to give me error. Q dot get, it is going to get the value. Int object is not subscriptable. It is going to tell me. So while not Q empty, let us check once. So without this, okay, let us take here. I also take n. For example, I will see is going to give me any correct or not, output as correct or not. So again, it is going to give me what? Same type of error. So here it is telling me what? It is going to take this integer value, and it is telling that it is not subscriptable, because whatever the value it is going to return is what here? It is going to return integer, so that it is telling that it is not iterable. Now 1 minute, I will tell you how it is going, how it can we can take these names. I want to take only the names. I don't want to take the priorities. So that just let us check the code once. Is there any problem here? I will check once. Okay, there is no, for this get I want to take subscript as 1. So let us try. I cannot. Q is giving me what? Q dot get is going to return me integer, and okay, right. A small mistake we have done here. What happens means, whenever I am going to take put, it is going to take what first value it is going to take, but I want to consider entire thing as, sorry, I want to consider entire thing as what? One entity I have to consider, so that I have to write what? One entity I have to take tuple. So in that one, now observe carefully, q dot empty. Okay, until q dot empty it is going to take that. So q dot get, that means entire tuple is going to be given. In that I want to print first one, that is based on the priorities is going to print. Now observe carefully. And now see, it is going to give what? Shiva, Rama, Prasad, Kollu, it is going to give. So I will not take this end here. I will not take end here. So observe the output now. It is going to print in line. So see, according to my order, it is printed because I have given first priority as what? Shiva. Second priority as what? Rama. And third priority as what? Prasad. And last one as what? Kollu. So this is about here the concept of priority queue. What is the mistake we have done means, it is telling that int cannot be subscriptable, because if I am not taking this one, it is going to, if I'm not going to consider it as a single unit, it is going to take only first one. And here, instead of this q dot get, we are going to get what? One value. From that one, is there any indexes? For int I cannot be iterable. It is not going to contain multiple values. It is going to contain only one value, so that it cannot be indexed. The index cannot be worked here, so it cannot be subscriptable. So that what we have to take, whenever we are going to give the priorities for the values or a strings, then we have to go for the concept of tuple. It has to be considered as single entity. So this is about the different types of queue we can use, but generally we will use what? Normal queue class only. But in queue we are having what? Three types. First is FIFO queue, which is nothing but our normal queue. Second one is LifoQueue, and third one is priority queue. So fine, this is about interthread communication. So in interthread communication, we have seen about how to implement, in how many ways we can implement interthread communication. First one is by using event, second one by using condition class, and third one by using the queue. By using what? Third one by using the queue class. So in this queue, we are having what? FIFO queue. We can take the varieties FIFO queue, which is nothing but a queue only. Next, we can go for LifoQueue. Okay, and third one we can go for priority queue. We are going for priority queue. So this is about interthread communication in our Python.